10, 11, and 12, we're solving a basic trigonometric equation. This time it doesn't give you the parameters that you have to be between 0 and 2 pi. So they're going to have answers that look like this. X equals 2 pi over 5 plus k pi. K is an element of z, which is the integers. That would mean that every 180 degrees. So 1 times pi would be 180, 2 times pi would be 360, and so forth. Now that's normally what you use for tangent and cotangent. Occasionally we have it on the sine or the cosine, but most of the time tangent or cotangent. Sine and cosine's period is usually 2 pi, so it'll look like this. 8 pi over 7 plus 2k pi, with k being an element of z. So first thing we want to do is solve our equation just like we did before. So we're going to subtract our 1 and say, okay, the cosine of x is equal to 0. We're then going to go back on our table that we used before. And I didn't flash that up there. It's going to erase my board, but I can rewrite that. But you want this table again where you can look up your sine, cosines, and tangents. So since it was 0, we have pi over 2 was cosine, cosine pi over 2 and 3 pi over 2. So if I go back here, normally we would have said, okay, cosine of x equals 0 at pi over 2 and at 3 pi over 2. But notice those are exactly 180 degrees apart. Pi over 2 is 90, 3 pi over 2 is 270. So instead of writing two separate answers, we can combine this into one answer, starting with our pi over 2 plus k pi. I'm going to go 180. So if I add 180 to this, I'd be at 3 pi over 2, and then I just keep going half a circle, half a circle, half a circle, half a circle. K being an element of z, that means I'm going to take it times 1, times 2, times 3, times 4, and it's just going to go on and on forever. Normally, you have two answers, but because these two angles were exactly 180 degrees apart, we can combine it into one answer instead of putting in two separate answers. Let's look at the next one. It says the sine of theta minus 1 equals 0. So I'm going to add 1 and look up where the sine of theta is equal to 1. So looking at my chart, sine equals to 1 is pi over 2. And that's the only one I see. So we just have that one answer, pi over 2. Now on this one, since my period is 2 pi, it's going to be at pi over 2, and I'm just going to keep going around my circle. This one I'm going to use 2k pi. And k has to be an element of z. So we only had one place on our circle, and to get around our circle every time we have to go 2 pi, 2 pi, 2 pi, 2 pi. So our answer looks like that. Normally we'll have two answers that look like that, but we only had one that was equal to sine of theta equals 1. If we look at the third one here, the third one's probably going to look closer to our answers normally. If I solve this, I'm going to add my square root of 3. So cosine of x is going to equal square root of 3 divided by our 2, since we have to divide by the 2 to solve that. So if I look up on my table, where is the cosine of x equals the square root of 3 over 2? We have at pi over 6, and then we have 11 pi over 6. So on this one, we're going to get two separate answers. Again, with sine and cosine, our normal period is 2 pi. So we're going to add 2k pi to both of those. And of course, k is going to be an element of z. These will be choices over at the sides that you'll have to click on. You won't have to type that, but you will join these with the word or, because I'm going to get two answers on this. Because pi over 6 and 11 pi over 6 are not 180 degrees apart or something that's divisible evenly, I have to do them two separately. So pi over 6, going around my circle a whole bunch of times, 11 pi over 6 going around my circle a whole bunch of times. So normally, again, for sine and cosine, you're going to add the 2k pi because you're just going to keep going around the circle once, twice, 3 times, 4 times. Occasionally, you can combine them if these are 180 degrees apart, or even if they're 90 apart, I can take pi and divide it by 2 and do 90, 90, 90, 90. But most of the time, our period is 2 pi, and so we're going to have that 2k pi on the end.